All right. So now you know how to multiply, or at least you've learned how to multiply. It's important you learn how to do that because the next thing we're going to be doing is something called factoring. Now, factoring in math essentially is breaking apart larger things into multiple pieces. So the simple version would be something like if you factor the number 10, you could say, well, what are the factors of 10, or factorize 10, or take 10 and tell me all the factors. Essentially, you're looking for all the little numbers that would multiply, whole numbers that would multiply to become 10. So you could say, well, all of the factors are 2, 1, I'm doing these a little out of order, 5, and 10. So you say, well, 2, 1, 5, and 10 are the factors of 10. You've probably seen these before. You maybe heard the greatest common factor, those kind of things. But ultimately, those are the factors. Now, if I were to ask you to factor 10, not just give me the factors of 10, you'd say, well, 10 could be broken up into 2 times 5. It could be multiplied 1 times 10. And that's it. So those are the factors of 10. And so notice how I'm grouping them in pairs, 2 times 5, 1 times 10. But there's other things too that you may not be thinking about. Like, it gets a little tricky when you say, well, what about -1 times -10? Those are also factors. So we're not just looking for positive numbers, we're looking for negative numbers as well. And then you got it, it's also -2 times -5. So there's a lot of ways that you can factor numbers. And in the same way is going to be going for polynomials. Essentially, if you look back at our examples here, we started with x plus 1 times x plus 3. We ended up with the trinomial x squared plus 4x plus 3. The question is, if I gave you this result, x squared plus 4x plus 3, could you tell me what the binomials were that created it in the first place? That's the process of factoring. It's going backwards from a complete polynomial or trinomial into its pieces or its factors in the same way that we took the number 10 and split it up into 2 times 5, 1 times 10, -1 times -10. So there's a couple of things that help you with this process. And when I was taught this, I basically said, figure it out. And I had to kind of process through it and reason and try to figure it out. And it was kind of a guessing game. My hope is to give you a little bit more structured way of doing this, so you're not just kind of guessing and checking until you get it. But it is helpful to think through the structure. Few things I want you to notice. Let's start with the first one for a minute. We started with x plus 1 times x plus 3, and we got x squared plus 4x plus 3. So the question is, where did this x to the second power come from? You'll notice that it came from, let me erase some of these highlights. That way it's easier to see. It came from these. The two first terms, x times x, gave you that x squared. So if you come back here and say, okay, well, if I'm starting with this and I look at just the first term, we say, okay, well, what makes x squared? What times what? And remember, using the distributive property, it's going to end up having to become x and x. So that's not too hard until we get more difficult looking trinomials. So we can kind of reason through that. So x times x gives you x squared. Then you say, okay, well, what's going to give you the same thing over here? You'll notice that, let me do another color. Let's do purple. The 1 times the 3 gave you the 3. Pretty reasonable. Gets a little more complicated if it was a 10, because is it the 2 and the 5 or the 1 and the 10? But we can kind of say, okay, well, to give me the 3, I know it's going to have to be this number times this number. So how could you make a 3? Well, it's not 2 times anything. It's got to be 1 times 3, and those are the only options. So we have a 1 here and a 3 here. And then the next thing you have to do is figure out, well, what symbols go in the middle? Like, I know that we already know the answer. They're additions or pluses, but they might sometimes be negatives, and they might sometimes be a combination of a negative and positive. But you kind of have to think through it and say, well, this must, in this case, is a 1. This one is a 1 here. So you can kind of reason through it, and really the way that you check your answer is by actually doing the multiplication with with the binomials with these here. You multiply this together and say, did it give you the answer that you wanted? But sometimes that becomes a little bit more complex. So even something like this, if I said, x squared plus, let's put in some numbers here. Let's do 10 here, and we'll do 7x. So the question is, what would that be if we just kind of guess and check? Well, using the method we talked about a moment ago, we know that this x squared has to come from the first two terms. So x times x is the only way to make an x to the second power. Once again, it does get more complicated later, but for now, x squared. Then we have to say, okay, well, how do we make that last term? And I'll give you some names for these in a minute, but a 10, how do you make a 10? Well, remember all that work we did up here. Those are all the different ways to make a 10. It's 2, 5, 1 and 10, -1, -10, or -2, -5. There's only 4 options. So you start out and say, well, which ones work? Use a guess and check method. Just to play the devil's advocate for a minute, let's use this term. So 1 and 10, let's try those two. So if I put a 1 here, and a 10 here, I just realized I wrote something very strange. So hopefully you see this. So x to the second power and x to the second power. Remember, it's not x to the second power twice. I don't know why I wrote that. It's x times x gives you x to the second power. If you caught that, nice job. If you were in my classroom, I'd give you a candy. So I'm throwing a Snickers at you. Anyway, so we know that this 10 times the 1 gives you the 10. So you think, oh, okay, we're done. Does that work though? Well, let's check it really quick. So if we do the distributive property, we do x plus 1 times x. So we have x plus 1 times x. Remember, it's the whole first binomial times the first term, x. And then we do x plus 1 times 10. Let me do this distributive property again. So x squared plus x plus, and then we do 10x plus 1, or plus 10. And then we combine like terms, and we end up with x to the second power plus 11x plus 10. Did we get what we wanted? Does this look like that? No, it doesn't. This term is wrong. It doesn't work. That middle thing didn't work. So what that means is we guessed wrong, essentially. So let me go all that work and say, okay, well, that didn't work. Let's try something else. Actually, let me leave that in there. That way, those of you who are looking at this later, you realize that those two didn't work. So let's keep those in there. So the 1 and the 10, okay, that didn't work. So let's try this again. Let's try, instead of the 1 and the 10, what were the other factors that possibly work? So nope. Let's try the 2 and the 5. Does the 2 and the 5 work? Well, let's try that. So let's come down here and say, okay, we want to make this work, so we know that this was not a good idea. Boop. Okay. So let's try these two numbers. Once again, we know that x times x has to be x to the second power, so that we know that works. Now we're going to try the 2 and the 5. 2, 5. Pluses in front of them. So now we're using the distributive property. We get the first term, so x plus 2, first binomial times x, plus, and then x plus 2 times 5. Then we use the distributive property again. We get x to the second power plus 2x, plus, and then we distribute the 5, so we get 5x plus 10. Now combining like terms, we have these two middle terms. We end up with x to the second power plus 7x plus 10. Did we get the trinomial we wanted? Yes, we did. So what was the correct factorizing or factorization of that trinomial, x squared plus 7x plus 10? It's the one that has the x plus 2 times x plus 5. So that's the solution, essentially. So these are the factors. So if I were to say, here's your trinomial, x squared plus 7x plus 10, and I'd like you to factorize it or factor it into binomials, you would say the answer is x plus 2 times x plus 5. So once again, I kind of used a guess and check method, but I didn't just try all the numbers in the world. How did I know which numbers to start with, or how did I know which numbers to try first? What I did is I took that last term, the 10, and I said, what numbers make up 10? Which factors are 10? And I only came up with these 4 options: 2 times 5, 1 times 10, -1 times -10, and -2 times -5. So you only really have 4 things to choose from. Now, I wasn't taught that till college. That didn't even make sense till I got to college. I just had to guess and check. But I realized that instead of guessing and checking from all the numbers in the world, you really only have to narrow it down to take that last term which we're going to refer to in a minute as the C term, and you break it apart into all its pieces, and you say, well, what numbers make up 10 if you multiply them? You get 2 and 5, 1 and 10, -1, -10, -2, -5. So you only have 4 things to choose. And it really doesn't take that long once you get the hang of it to try all 4 of those. And eventually you find the one that works, and there only will be one that works. And then you factored your polynomial. So next we're going to go through a little bit more systematic way. I'm going to walk through 2 methods of factoring. One is called, methods, or strategies, I guess. There's lots of ways, by the way. If you just Google how to factor trinomials, you'll come up with all kinds of different things. But I'm going to teach you 2 ways. One is called factoring by grouping, and that's the reverse distributive property. So that's the first method that I'm going to teach you. And then the second method is I'm going to teach you, I've heard it called the diamond method, the X method. I think I'm going to just call it the X method. It's just another way of organizing your work so it works. So typically between these 2, most people are like, oh, I like this one or I like this one, and they're kind of split either way. So you can choose which other method you like. So I'm going to show you both of those next, and then we'll move into some more advanced factoring from there.